Hello guys, welcome to today's tutorial. In our previous tutorial, I created this breed model that represents different breeds of cows in our dairy farm. However, I forgot to add a unique constraint to the name field. This means that it's possible for two breeds to have the same name, which could cause confusion and errors in our application. For example, one could save a breed by the name Fresian, then save another breed by the name Fresian. And to fix this, we can just add the unique is equal to true parameter to the name field, and this will ensure that each breed name is unique and prevent any duplicates. And with that change in place, we can now move on to today's tutorial. I went ahead and pre-populated the models with the attributes and several validation checks, and starting with the heat model. This model is a record of a cow being in heat and is associated with a cow model through foreign key relationship. As you may see, this is a foreign key relationship. And let's start by looking at the attributes of the heat model. First, we have the observation time attribute, which represents the date and time that the heat was observed. Then we have the cow attribute, which represents the cow that is in heat here. This means that every heat record is associated with a specific cow into the database. And now, let's take a look at the methods in the heat model. Firstly, we have the string method or the string function, which returns a string representation or rather a sentence of the heat record in the format heat record for the cow this of tag number this on self-observation time this. This makes it easy to identify the specific cow and observation time associated with the heat record. The second method is the clean method, which is used to validate data before saving. It's automatically run by Django when the models are saved. It checks several conditions to ensure that the heat record is accurate and consistent with the other data in the database. And now let's go through these validation checks. And let's start by the first check. The first check compares the observation time and the time zone.now. As you may already can tell, this is keyed in by the user, then it compares if it is greater than the time zone.now, then it will raise an error, observation time cannot be in the future. This is how the second check works. It accesses the pregnancy status of the cow that is to be saved and checks if it is equal to P, meaning that the cow is pregnant, then it will raise a validation error that the cow is already pregnant, because a pregnant cow cannot be in heat, and so this will be an error in the data. Then, thirdly, it checks that the cow is not already in heat. This is important to avoid duplicate heat records for the same cow. As you may see, it accesses the heat records for that specific cow that is to be saved with the heat record. Then it filters the range of the heat records that are already available, checks in the time zone.now, the very same time that the heat record is to be keyed in, and then subtracts 2 days. So if a cow was on heat yesterday, most of the cows are in heat for up to around 35 hours, and so giving it a higher limit of 2 days, which is 48 hours, makes it quite reasonable to filter within the range of 48 hours of the previous heat record. So if by chance there was already a record falling within the 48 hours, then it will raise a validation error that the cow is already in heat. And fourth, it checks that the cow is alive. Obviously, a dead cow cannot be in heat, so it will check the availability status of the cow to be saved with the heat record. And then if it's D, which is an equivalent to dead, as you can remember from the previous tutorial, it will raise a validation error that the cow is dead and cannot be in heat. Then fifth, it checks if the cow is a female. Only female cows can be in heat, so this is an important validation. It goes ahead and checks the gender of the cow, equates it to M, which means that the cow is a male. If it's a male, if this validates to true, it will raise a validation error. Heat can only be served in the female cows. And this is how the sixth check works. It goes ahead and checks the pregnancy status of the cow. If it equates to C, which means that the cow just calved within the 60 days, it will now confirm whether the observation time that is being entered for the heat record minus the time that the cow had calved is less than 60 days, which is actually the threshold. It will raise a validation error that cows cannot be in heat within 60 days of calving. And then the seventh check, it validates that the cow is not in heat within 21 days of the previous heat observation. This to ensure that we do not record heats too frequently for the same cow. It makes sense because most of the cows, their heat cycles always falls between 18 to 24 days, so an average of 21 days makes sense. And now this is how the Check 7 works. It goes ahead and accesses the cow's heat records, filters them based on their last 21 days and the time zone.now, and evaluates it based on true or false. So this exists will return a true or false Boolean value. So if it returns true, it will raise a validation error of this cow cannot be in heat, or actually the cow cannot be in heat within 21 days of the previous heat observation. Finally, it checks that the cow is not less than 10 months old. A cow must be at least 10 months old to be in heat. So this is an important condition to check. That's a brief overview of the heat model and its validation conditions. And so if you're working with the cow data, the heat model is an important tool for tracking when cows are in heat. Therefore, let's move to the next model, the pregnancy and the lactation models. And so let's shift gears to the pregnancy model. This model is used to keep track of the pregnancy status of a cow in a herd, and it has the following fields. It has the cow, field of the cow attribute, which is a foreign key to the cow model, representing the cow that is pregnant or to be set as pregnant. The start date, that's the date when the pregnancy began. Then the date of calving, the date when the calf was born, or none if the cow has not given birth yet. Then there's the pregnancy status, that's a character field indicating the status of the pregnancy, with 3 possible values of C for the confirmed, U for the unconfirmed, and F for the failed. The pregnancy notes is a text field for any notes related to the pregnancy. The calving notes is a text field for any notes related to the calving. There could be difficulties and any other things related to calving. The pregnancy scan date is the date when the pregnancy was confirmed, or none if the pregnancy has not been confirmed yet. Pregnancy fail date is the date when pregnancy failed, or none if the pregnancy did not fail at all, meaning that the cow carried the pregnancy up to term. Then the is pregnant is a Boolean field indicating whether the cow is currently pregnant or not. It returns true or false. By default, it's true. The pregnancy outcome is a character field indicating the outcome for the pregnancy, with 3 possible values of L standing for the live, S for the stillborn, and M for miscarriage. Blank is equal to true means that if we save it today, the cow will give birth the next 9 months, and it does not make any sense to have the pregnancy outcome field populated, and that's why blank is equal to true, meaning that it's not a required field. The model has also 2 computed fields, the pregnancy duration and the due date. The pregnancy duration is the duration of the pregnancy in days and is computed as the difference between the date of calving and the start date, or none if the cow has not given birth yet. Sorry, there was an error here. The due date is the expected date of calving, computed as the start date plus 260 days, or ended if the cow has already given birth. The 260 days is just a guess, but it could be 270 to 80. This could be depending on the cow. Let's assume that it's now 270, because 270 translates to 9 months. The pregnancy model has clean methods that perform several validation checks, and here is an overview of each of the check. The first check checks that the cow must at least be 1 year old to be eligible, or actually to be pregnant. As you may remember in the previous tutorial, we had this function getCowAge that returns the age of the cow in days, and so it checks a single month has around 30 days or so. So if you multiply by 350, roughly 350 equates to 1 year, and so if this one is violated, meaning that if the cow is less than 350 days old, it will raise this validation error. This cow must have pregnancy threshold of 1 year, and then we move to the date of calving. If the date of calving is provided, meaning that if self or date of calving is provided and the pregnancy status is not equal to confirmed, it only makes sense that if the date of calving is provided, meaning that the cow is given birth, the pregnancy status must have been confirmed. So if that is violated, it will raise a validation error. Pregnancy status must be confirmed if a date of calving is to be provided. Moving forward to the next check, we check if the date of calving provided is in future, and if so, it will raise this error. We also check for the availability status of the cow. If the cow is dead, it will raise this error, and if the cow is sold, because the availability status of a cow can change over time in the farm. The cow could be alive, could be dead, or could be sold, and the sold cow cannot have any pregnancy record in that very specific farm. And so if the cow status had already been set as, it will raise a validation error of the cannot add pregnancy for a sold cow. If the cow is a male, it will raise a validation error. This is a male cow and can never be pregnant. And if the start date and the due date are there, and then the start date is greater than the due date, it does not make any sense, because the due date has to be in future. Because if we set a cow to be pregnant today, in February 2023, the cow only has to give birth around maybe November. So if that one is violated, the start date must be before the due date. And then, if the date of calving and the start date are both provided, meaning that the cow had given birth, and the date of calving that is provided is less than the start date, it will raise this error, because a cow only gives birth later after the start date of the pregnancy was recorded. If the date of calving and the end date are provided, and the date of calving is greater than the end date, it will raise a validation error, but the date of calving must be before the end date. And this is a redundant check. For now, it doesn't make any sense, but I was trying to apply it somewhere that maybe in future we'll see how it works. For now, let me comment it out. Moving to the next check, it will check if the pregnancy scan date and the start date had been provided, and the pregnancy scan date is less than the start date. It does not make sense, because the pregnancy scan date can only be done after the start date had already been recorded. So it will raise this error if this is violated, that the pregnancy scan date must be after the start date. And if the pregnancy scan date and the due date are there, and the scan date is greater than the due date, it does not make any sense, because it has only to be scanned within the pregnancy period of the start date and the due date, and the pregnancy scan date cannot be availed or cannot be in future. And then moving to the next check, if the outcome of the pregnancy is L, meaning that the cow is live, and the pregnancy status is not equal to confirmed, the syntax is exclamation mark is equal. So if this is violated, the pregnancy status, this error is raised. The pregnancy status must be confirmed if the outcome is to be provided. Outcome could be either L for live, S for stillborn, or M for miscarriage. All these have to have a confirmed status, because it means that the cow was actually pregnant. And moving to the next check, this confirms if the outcome L and the date of calving is not provided, because if the outcome is L, meaning that the cow had given birth, it will restrict and it will raise this error. The date of calving must be provided if the pregnancy outcome is live. If the start date is greater than now, it does not make any logical sense, because you cannot key in data for the cow that it will be pregnant tomorrow. So it will raise this error. The start date cannot be in the future, and the pregnancy scan date cannot be in future. If the pregnancy status is F, equating to failed pregnancy, and the pregnancy fail date is not provided, it will raise this error. A pregnancy fail date must be provided when the pregnancy status is failed. The pregnancy fail date cannot be in the future, and the pregnancy fail date cannot be earlier than the start date. If the pregnancy outcome is M, meaning that the cow miscarried, and the pregnancy status is not set to F, meaning that the pregnancy status is not set to failed for this miscarriage, then it will raise this error. Pregnancy status must be failed if the outcome for pregnancy was a miscarriage. If the pregnancy outcome was S, meaning that the cow has given birth actually, but it's a stillborn, and the pregnancy status was not set to confirmed, then it will raise a validation error of pregnancy status must be confirmed if a pregnancy outcome is stillborn. And then I move to the last model for this tutorial, the lactation model. And so let's finish with the lactation model. This model will represent a period of time when a cow is producing milk, and it will be used to keep track of the milk production of each cow on the farm. The lactation model has the following fields: a start date, which is a date field that represents the start date of the lactation period, an end date, which is a nullable field that represent the end date of the lactation period. In the lactation stage, that is an integer field that represents the stage of lactation period. This field is calculated automatically based on the number of the days that has passed since the start of lactation period, and as determined by the property or the method days in lactation. The cow is a foreign key from the cow model, which represents the cow that is producing the milk. Then the pregnancy is an attribute or a field that has a one-to-one relationship with the pregnancy model, which represents the pregnancy that led to this lactation. The lactation number is an integer field that represents the number of lactations that the cow has gone through. The lactation model has also the following methods. The days in lactation. This method calculates the number of days that have passed since the start of the lactation period up to the current date or up to the end date, if it is set. Then the lactation duration. This method calculates the duration of lactation period in days. And then we've customized the save method. This save method is overridden from the default save method that Django provides, and this automatically sets the lactation stage based on the number of days that have passed since the start of the lactation period. And so, I'd like to introduce a new concept. We call them signals. These signals are very handy for models that depend on each other. For example, the lactation model and the pregnancy model are related in somewhat a way, as you will see. So we go to the folder where this is the dairy app, then we click, then we add a new file. The new file, we will name it signals for clarity, so that we may not get confused in future if maybe we have several files with almost similar names. So we save it, signals. I'll go ahead and pre-populate this file with the necessary code and explain line by line. And now that the signal file is already pre-populated with the necessary code, I'll go ahead and explain them line by line. But first and foremost, I'll briefly explain what Django signals are. Django signals are a way for different parts of Django application to communicate with each other. They allow certain senders to notify a set of receivers that some action has taken place. In this case, the lactation and the pregnancy. For example, when a cow is calved down, we will want to automatically start the lactation period. So, in Django, signals are implemented using the built-in signal class, and there are two main types of signals. There's the pre-save and there's the post-save. This one imported here. The pre-save signal is sent before an object is saved to the database, and the post-save signal is sent after an object is saved to the database. To use signals in Django application, we need to define a receiver function that will be called when the signal is sent. The receiver function should be decorated with the receiver decorator, this one here. Some of the stuff are handled under the hood for you. So when the signal is sent, all the connected receiver functions are called in the order in which they are connected. Overall, Django signals are a powerful tool for building modular, extensible applications, and they can be used in a wide variety of contexts, from auditing changes to a database and triggering complex business logic in response to user actions. The first signal handler is for the pre-save event of the cow model. It updates the status field of the cow model to D, which is dead, if the date of death is set. The second signal handler is for the post-save event of the pregnancy model. It updates the pregnancy status field of the cow model to P if the pregnancy instance was just created, indicating that the cow is now pregnant. If the pregnancy instance was not just created, it updates the pregnancy status field to C, meaning that the cow is just calved. It then saves the updated instance. Sorry, I forgot to save it. Let me just save it. Instance .save. The third signal handler is also for the post-save event of the pregnancy model. It creates a new lactation instance if the pregnancy instance was just created. To create a new lactation instance, it checks if there's a previous lactation instance for the cow and if it has ended. If there's a previous lactation instance that has not ended, it sets the end date to 1 day before the lactation instance, and then creates a new lactation instance with a start date set to the date of calving of the pregnancy instance. The cow set to the cow instance associated with the pregnancy instance, the pregnancy set to the pregnancy instance, and the lactation number set to 1 if there is no previous lactation instance, or 1 plus the lactation number of the previous lactation instance if there is 1. This signal script is designed to keep the cow and the lactation models up to date based on the changes on the pregnancy model. Specifically, it ensures that the cow model status and the pregnancy status field are updated correctly and the new lactation instances are created when the associated pregnancy instance is created. And so I'll go ahead and register these models to the admin.py and see how they look in our admin site. So I went ahead and registered the two models, the lactation model and the pregnancy model, in our admin site. And so if you might remember, we need to run this code to ensure that all these changes are applied to the database. All we need to do is run the python manage.py make migrations, then it will give us the file for the changes, then actually migrate them by the python manage.py migrate. This applies them to the database. Then all we need to do is now to run the server, python manage.py run the server. Then the server is up and running. Now I'll go ahead and sign in, Peter Evans, then log in. So we'd want to confirm that if a pregnancy record is added, assuming that we had for the second cow, it gave birth maybe last year, January 1st, so it must have curled down around October there, or maybe September. So let's assume it's September 30th. So let's give it confirmed in the live. We want to check if the signal is actually working. That means that the lactation is automatically added or saved. Okay, this guy is already pregnant. Seems like the other tutorial that we did the other time, we left it at a pregnant state. So I'll go back and give it not pregnant status, save it, then come back and try again. First of January and maybe October 31st, the pregnancy status was confirmed, then the calf was live. So if you save it, we have this one pregnancy record. The cow, the start date was January 1st, 2022. This was the date of calving. The pregnancy duration was 303. Then the due date cannot have this date field because it had already ended. So we're going to check at the lactation records, and actually we find one. See, this lactation stage, the calf was given birth on October 31st. So it means that based on our definition of the lactation stages, 0 to 100 days, then 100 days to 200 days, those falls between the mid lactation. So this makes sense. And now these are the details of the lactation object. This one changes based on the number of days of the lactation. And so that's it for this tutorial. See you in the next tutorial. Bye bye.